Guess what? If you guessed that we were going to do another lesson, then you are correct. Today's lesson is on rational numbers, putting them on a number line and on a coordinate plane. So our learning target is I can place rational numbers on number lines and coordinate planes, and our vocabulary words are quadrants. You should already know those. The quadrants are the four sections created by the x-axis and y-axis. So the upper right is quadrant 1, the upper left is quadrant 2, the lower left is quadrant 3, and the lower right is quadrant 4. That's all you need to know about that. The rational numbers. Any number you can exactly locate on a number line are rational, such as whole numbers, fractions, decimals, and integers. Almost everything's a rational number. The word rational outside of math usually means just makes sense. Like, I'm completely rational. Okay? The opposite of rational is irrational. Mrs. Carlson is irrational. It means she doesn't make sense. So an irrational number is a number that you can't actually identify where it is on the number line. An example of an irrational number is pi, because the decimal never ends and never repeats. Pi is approximately, I should put approximately, 3.1415936, I think, and it just keeps going. So you can't really find that perfect spot on the number line since it keeps going forever. There's other examples of irrational numbers, like the square root of 2 is another decimal that doesn't end, and doesn't repeat. Another example of an irrational number. The golden ratio. The golden ratio, which looks like a symbol like this. You can look up the golden ratio. That's an irrational number also. Okay. Back to the vocabulary words. Ordered pair. Two numbers in parentheses that give a location on the coordinate plane. They're always in the order x, y. So an example of an ordered pair is 1, 4. Remember, that means over 1 and up 4. So -2, -3 means left 2 and down 3. All right. So your steps for your learning target. To place numbers on a number line or a plane, you need to understand your intervals. So on a number line, any kind of number line, the intervals, the spaces between each tick mark, have to be exactly the same on the entire number line. So from 0 to 1, you can see that there's 5 spaces. It takes 5 tick marks to get to 1. So that means that each space is either 1/5 or, as a decimal, 0.2. Let's just use decimals. So if the first space is 0.2, the next space would be 0.2 more, so it'd be 0.4 or 2/5. The next one would be 0.6, the next one would be 0.8, and then 1.0. So this tick mark would represent 0.2 more than 1, so 1.2, 1.3, that's wrong, I was testing you, 1.4, 1.6, 1.8, and then 2.0. Had trouble with my 8. Okay, so if you look at a number line that has negative numbers, the same thing's true. These tick marks have a distance of 0.25 between each tick mark. So from 0 going to the right, it's 0.25, 0.50, 0.75. Think of it like 25 cents, 50 cents, 75 cents. Going the other direction, it's the same thing. Negative 0.25, negative 0.50. The distance between any two tick marks is 0.25. Any two tick marks that are next to each other. Alright, so the first thing you do is understand your intervals. The next thing you do is realize that positive digits get bigger from right to left and negative digits from left to right. So I'm just talking about the digits. So to the right here, they get bigger. 1, 2, 3, 4, 5, 6. And it's going to get bigger the other direction. It's just going to be negative. Negative 1, negative 2, negative 3, negative 4, and so on. Alright, so an example that you need to put in your notes. We're going to plot negative 1.5 on a number line. So let's put 0 here, and I know that I'm going to need 0.5s, so I'm going to skip a space and put 1, 2, 3, like that. That means this first space is 0.5, the next one between 1 and 2 is 1.5, and so on. Let me get the 0.5 on there. Alright, and now it's going to be easy to find negative 1.5 because it's the opposite of 1.5. So in other words, if I go 1, 2, 3 spaces to get to 1.5, I'm going to need to go 1, 2, 3 spaces to get to negative 1.5 since it's an opposite. So that means that this first tick mark to the left of the 0 is negative 0.5, the next one's negative 1, and the next one's negative 1.5. So that's the location of negative 1.5. Okay. So the next step, step number 3, if you're plotting a point on a coordinate grid, remember that left is negative on the x-axis and down is negative on the y-axis. So our example that you need to put in your notes, when you put this in your notes, don't draw all of the little lines. Don't draw these lines in. Just draw the axis. Just draw this one and label them with an X and a Y, and then you can make little marks for each number on the axis. So we're going to plot 2.5. So 2.5 is the over 2.5, and negative 3.5 is the up negative 3.5. So when we go over 2.5 from the origin, that's going to be exactly right here. So that's over 2.5, and then we need to go up negative 3.5. So from that point, right here, I need to go up negative 3.5. That means down 3.5. So that's going to be So what I just realized here is that these numbers are not lined up very well. So let's just clear this up instead of getting a new graph. This 1 is supposed to be right on that line. It should be written right here. This 2 should be written right here, and so on. So when I'm trying to find my point, 2.5 comma negative 3.5, I went over 2.5, and now I need to go down negative 3.5, so I'm going down 1, 2, 3, so negative 3.5 is going to be right there. Okay. Now, you don't have to have the lines drawn. Those are just for help. So I'm going to go ahead and erase those. And I'm going to label my point when I'm done with its coordinates. So this point is 2.5, negative 3.5. All right. So now you should know enough to get your quick check done. You don't have to draw the grid. You don't have to draw the coordinate plane. Just draw, or just write the coordinates. So just put A, give me the ordered pair. B, the ordered pair. And C, the ordered pair. Good luck. See you soon.